Okay, I think we are live. All right. Um, so hello everyone and welcome back to another live stream. In this live stream, I'm gonna continue working on my parser, I guess. So the last episode we did some stuff. Okay, I don't want to talk about it. I don't know. It's like this is a live stream, no one's here, it's fine. Um, okay, let me check. Let me open the doc. I think I want stats. No, I don't want stats. Just close the dockable window. Okay, okay, YouTube live control panel. Okay, that should be good. It says excellent. Okay, whatever. So now, what I'd like to do is, continue working on my parser. So I will need to create more binary, expressions here. So first of all, let's sort them and make sure that they're, like, compatible. This is not binary, this is a pre-unary. Yeah, so these are equality things. I guess I can work on that. Or what I can do is either that or I can just add more statements. Control statements, right. I think, honestly, for a change, I think I want to work on the control statements. So, next we're going to go to parse stmt. And we're going to basically say, hey, is this an if statement, an else statement? Oh, there should be else. Okay, I should add that. If there should be else. Else. Nope. Whoops. Nope. 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 I don't think I want to use this keyboard. Okay. Let me use my laptop keyboard. Okay. Go. Okay. Maybe I should, like, tell... Should I tell my friend that I'm live streaming right now? Alright, I'm live streaming. Haha. Okay, there you go. Okay. So now... Alright, so I have if else. So I want to add support for various statements. So parse statement. Okay, so... I think my parse statement should probably do a variable declaration first. Maybe we could do that. Maybe I could do that. Okay. Okay, okay. Alright, let me not get distracted by, my Discord stuff. Okay, let's do this. So, parse statements. I think I would like to support variable declarations. So, if this is an L brace, if this is a brace statement, else if res.kind is equal to token type dot var, I guess. We're gonna eat that token. This is oh no, we're not gonna eat that. We're gonna just create a variable declaration statement. So, variable declaration stmt. Okay. I'll just do children dot push this dot parse var decal. So I'll just let my variable declaration parsing code take care of it. Okay then. Now what? Oh, whoops. Okay. Now what do we do? That's a very good question. I don't know, man. Like, man, come from poverty. Sorry. Okay. Let me just edit my docs. How do I, like, edit the OBS? Oh my gosh. No. Oh. Okay, that's live chat. Okay, whatever. Okay, okay, let's see if I can like declare variables now. Let's see what happens. So this is not happening. Oh no, this is working. I'll just do local var is equal to 10. It's equal to string here. I will do string. There you go. And then we'll just clear source. We'll run that again, see what happens. Right, now there's an stmt, which is a variable declaration right there. Just nice. Good, good. What does that mean then? That's a good question. Um, I don't know. Okay, but that's good that we support variable declarations now. So, these are control statements. Variable declarations are not control statement. Other statements. All other statements whose tokens are currently supported. Currently supported. What else? Var. For the future. Whatever. Okay, so now let's now we have the variable declaration. Now we actually want a an if statement. Let's do that. So else if res.kind is equal to token type.if statement. If statement. Okay, so what is expected in an if statement? Well, we have this conveniently, we have an if statement here. So we first want to eat that variable that is an if statement. So f dot this dot next token, we're gonna eat that. It's gonna be the if. And then we want to find a parenthesis basically. So this dot seek token expect types. No, next token expect types. Token type dot l parent. Right, and this should be res. So res bool is equal to this. If not bool, so if it's not, if it returns the wrong thing. So if there's an invalid syntax here, it's just gonna return this dot make error branch. That's good. Now that's left parenthesis. Now we just want an expression. So this dot parse expression. So I'll just do children dot push. We're gonna parse an expression. It should be a conditional expression. And then we'll do children dot push. I don't know, that's it. And then right, and then we expect an R parent, a closing parenthesis. Good. And then we expect a statement. So children dot push. Wait, no, yeah, children dot push this dot make parse stmt. Right, and once we have a statement here, now we're gonna try to find, hey, there should be an else block, or there could be an else block. So this dot seek token expect type, not expect type, we're not gonna expect anything. It's gonna seek token. Okay, if res.kind is equal to I think this should be a while true. While true. Wait, no. It's either like if there's no else statement or there's one else statement. And then like when there's an else statement, if it's an else if block, then it could be like it'll be taken care of by this parse statement right here. You know what I'm saying, right? Like so for example this one. If else, right? But then the next statement, the statement for else is gonna be if and then else. And then you know what I'm saying? Like I don't know. Okay, res.kind, what is it? If it's an else, oh wait, no, I forgot. I need to write the code for an else statement here. So I need to include the code for that. Yeah, case else, right? And we just do else. Okay, parse stmt. So if it's token type dot else, we're gonna do this dot next token, this dot next token, and then we're gonna do children dot push this dot parse stmt. So whatever that statement within that else statement is gonna be, right? Token type dot else, and then okay, is it gonna return anything automatically? How is it gonna know if it's an if statement though? I feel like this should be like a different type. Okay, so instead, okay, there's gonna be a kind. It's gonna be a token type is equal to token type dot should be none. Oh no, it should be a token type. It should be a branch type. None. It should be branch type. And then it not is block, but it should be kind is equal to branch type dot for a block statement. Kind is equal to branch type dot var decal. Wait, no, but this is gonna just say. Oh, I feel like it should be like. Should var decal be a different kind of statement, or should it just be var decal? I mean, we don't want to make it too complicated, so we could just do like return this dot var decal. No, but it should be a statement anyway. So, hmm. Yeah, whatever. Doesn't matter. Let's just set it to var decal statement. Var decal stmt. Here, I'll just do if stmt. Now we just need to declare var decal stmt and other type of stmt, other type of statements. So var decal stmt would be t, and then we want not just that, but what if stmt, I guess. And while we're at it, we might as well do while. If while. What other token types do we support here? If while, return while for, return while and for. So I guess we'll do return, we'll do for. If it's semi, then it's just gonna be an empty statement. We'll just by default, I don't know, kind is equal to token type dot stmt. No, not it should be branch type. What? It's just gonna be stmt anyway. So extra. Oh, there should be an extra statement then. Kind is equal to branch type dot express stmt. No, but I feel like stmt should just be. No, I think this is fine. Let's make sure that this still works. Yeah. So now we'll try to see. All right. We'll comment this out and we'll do a if string. Let's do like string compare. String with high. Wait, no, we can't really do that. Because it doesn't support double equals yet. This one, right? And then we'll do code here. So let's do printf they're equal. Do else if string compare string hello printf. Nope, I don't know, man. Else failure. There you go. Let's see if this works. This should work. Ooh, unfinished string or char due to new line. Oh, sorry, that's my problem. There you go. Unfinished string or char due to new line. Oh, here. Oh, okay. There's no error. Okay, okay. What do we have here? So we have function call. So we have an if statement, and its first thing is a function call. It first is first kind of thing is a first child is the expression, the conditional expression. It's a function call. Good, good, good. Right. And then the next one is an expression statement, and then the other one, which is the else, is another if statement, which the expression statement statements. Okay, it's just an expression statement. Good, which also has another else thing, and that's good. That's good. Okay, good. So the if statement is working. So now yeah. So we support if statement right now. Let's do something. Let's do while. All right. Parse stmt. Okay, let's do while. I mean, I did say that I'm supposed to use expressions. I did put in my title that I'm supposed to make my parser support more expressions for my custom programming language. But here's the thing, right? What's it called? It doesn't, I'm basically disobeying what I'm saying, but whatever. Maybe I should change the title. How do I change the title? Maybe I can, like, how do I, like, oh, I can't change that? Oh, well, that's too bad. Alright, we'll add a while statement. So, it's an if statement. So, else if res.kind is equal to token type dot while statement. So if it's a while token, we're just gonna say, hey, we're gonna keep that token, and then what? We expect a conditional. I think the for loop would be a bit complicated. I have to say. No, I think it's fine. But we're focusing on while right now. So what we want is a base statement. We want an if statement, something like this. yeah, we want this. Yeah, it's basically an if statement without, it's just that it starts to while. Its structure is basically like that. So we're just do this. Um, yeah, yeah, it does this. It parses a statement, and yeah. And let me just make sure that the kind, we'll set the branch type to while because it's a while statement. Sorry, while statement. There you go. Okay. So yes. Okay, good. Okay, let me just add the spacing. Um, our parent, and then here's the actual block, the statement. Body of while statement. There you go. It should be a body of if statement, else statement. It's not really treated as a statement here. It's just whatever. Okay. As its own statement, it's just part of the if overall statement in my abstract syntax tray. Okay. Let's go do some. Okay, while statement. Okay. Good. So now what do we want? What we want is to test it out, see if it works. So I'll just like, I'll comment this out. While true, we'll have to did we make true a variable? No, we'll just do while one. Printf hi. Okay, let's see if it works. So here, func deco, right? In the block statement, there's what? A while statement, right? And then we're gonna express lint, right? So, yeah, so that's the conditional. And then and the body of the while statement is a block statement. And so there's an expression statement, in there, which is a function called, printf, right? With the argument hi. Yeah, it's good, 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 good. Okay, good, good. Working like a charm by the grace of God. Okay, now what we want to do, we want to get rid of this console.log first, but we can remember those later. So now we go to branch type.while. Okay, yeah. So now we want to support a for loop. Why not, right? So else if res.kind is equal to token type dot for. This is a for loop. And what is the for loop? First of all, I'm gonna set the branch type to for. Okay. There you go. So that's gonna be the for, and then now we're gonna expect a left parenthesis. First of all. Right. And then now we want an expression. Conditional, okay, no, expression one. There you go. Expression one, the x in for x. Yeah. So now we want to do children dot push. This dot expression, no, this dot parse expression. There you go. And then we do this dot next token expect types. Now we want a semicolon. And then we're gonna do the second expression. And I want the Z. Okay, I think that's good. And then now we just expect a right parenthesis. And then we do the body of the for loop. Okay, let's see if this works. So we'll do, that means this kind of statement will work, because that's just the while true, and you could just do while one, right? Alright, anyways, so for var I is equal to 0. Oh, it should have hmm, x in, yeah, I think this shouldn't be an expression. This could be a statement. Expression 1, expression 2. Yeah, I think this should be a statement, and that means you can make an if statement inside that. But I think that's okay. I think it should be fine. And then let's do if whatever. Okay, parse stmt. Okay, statement 1, expression 1, expression 2. Okay, I think that should be good. Yeah, so that means it should be var I is equal to 0, I is less than 100. Well, no, that we can't really do that, but let's do continue. And we haven't done variable assignment yet, so. Alright, let's see if this works. This should work. Ooh! Expected semi, but got ident. Something's wrong. Okay, L parent, yes. We parse statement, yeah. Oh no, because okay, because it's a statement. The statement should, because there should be a semicolon. Okay, okay. Um, hmm. Because that would mean then that because there should be a, we want a semicolon though, to separate them. That means that either Bardeco should not listen for a semicolon at the end. Okay, let's do that. Parse var decal. We're not gonna listen for a semicolon at the end, right? No, but it's gonna eat it anyway. I think, either, okay, well, okay, if that's not the case then, because it's gonna eat this statement. It's gonna eat this semicolon. So should I just, um, double check? No, no, no. I think maybe I could just like, okay, because if I don't, whatever. Okay, where's the for statement? This is not it. This is the if statement, isn't it? Wait, what? I'm so lost. Okay, here. So this is the if. This is for. There you go. Found it. So now all I need to do is what's it called? Yeah, I'm not gonna expect a semicolon. And then I'm gonna run this. Yeah, no errors. Good, good. Okay. So let's see if this is correct. So the example code has 4 variables. Okay, so for statement is a variable declaration statement, which contains a variable declaration. That's good. And then should continue. So this is the expression, conditional expression, and this is the increment kind of thing. Yeah, whatever. And then the block statement. That's gonna work. Okay, good, good. So we got the for loop done as well. So what do we have here? So we have while and for. Now we just need to support return. So branch type dot while statement. Okay. So now we'll just do a return statement, and I think we should do a break. And other kinds of statements. Okay. Yeah, so let's do a return statement. Return statement, token type of return. Okay. This dot next token, we need that, and we're gonna call this kind is equal to a branch type dot token return statement. Okay, good. Should I turn my should I turn on my camera? Like, I don't know, man. Hahaha. No. Okay, so now we want to oh, okay. Yeah, so this is gonna be a return statement. So either it's gonna expect a semicolon or something else. So res is equal to this dot seek token expert. Okay, so okay. If not res if res is equal to this dot, if res dot kind is not equal to seek token. Wait, what? No, no, no. It's not a token type dot semicolon. It's not a semicolon. It has to be an expression. So children dot pushback, not pushback. This is not C++ vectors. What are we gonna push? Branch type. No, no, no. This dot parse expression because we just want an expression, man. Once we do that, now we just do okay. This dot next token expect type. So we're gonna expect a semicolon. Right, so let's see. So for a return statement, we're gonna eat the return statement, and now we're gonna seek the token. We're gonna see, okay, is it a semicolon? And if it's not a semicolon, we're gonna find an expression there. But if it is a semicolon, then we're just gonna go straight down to here, where we eat that semicolon. Not a semicolon, then we make an error branch. Okay, so that should be good. Okay, let's see. So there should be 2 types of return statements now. So I'll just comment this out, and I'll do, okay, return 1 plus 1 and return just nothing. We have nothing in there. Okay, no errors. Good, good. So return, yeah. So the block statement is a return statement that involves an addition expression. And then, right, and then there's a return statement that doesn't involve anything. That's just it. And let me make sure that an if statement works. So if 1 and f. Okay. Yeah. So after the empty return statement, we have an if statement with a conditional expression here, and then a function call expression here. Statement, basically. Okay, so that's good. Right, so basically supports turn. Yeah, else, yeah. We do that. We have that. I think break and continue. Do we have break? We already have break. Wait, no, we don't. Okay, let's go to token type. I'm gonna add break and continue statements. Well, okay, keywords first. So, yeah, we'll do a break. Nope. Break. Whoops. No. Break and then continue. Sorry. Okay. Wait. Now I need to like. Sorry. Okay. Okay. There you go. There you go. So yeah, we got break and continue. Now I want to support those two. So last statement. Okay. So now we just break and continue. Okay. Now I just do. So this is empty statement. Okay. Else if res.kind is equal to token type dot break. Wait, no, I haven't even like hold that thought. Um yeah, I didn't even like register that keyword yet. Okay, I'll do that. It's break, the keyword is break, then we'll do break. The keyword is continue. Then we'll whoops. Then we'll continue, I guess. Okay, that should be good. Okay. And a break statement is just the keyword break and then a semicolon, right? So and the same goes for continue, it's just a different keyword, although I will have to remember to set the branch type to break statement. Oh, I don't even have that. Okay, let me add that there. Break statement. Okay, what else? Break, continue. There you go. And now I just need to copy and paste this, but make it continue. Continue statement. This should, okay, so now, theoretically, put this within a loop. I mean, it's still going to register it, but okay, we're going to have a, what's it called, an AST verifier, so it's going to verify the abstract syntax token later. Just like how my Lexer has a token verifier, so it verifies the tokens, whatever. So now we'll just do a, what's it called, okay, break, and then continue. Break, continue. We don't have an error, do we? Okay, so we have while statement, and this is its, yeah, true, okay. And then block statements, break statement. Yeah, so in our block statement, we have a break, and we have a continue statement. Break statement, and a continue statement. Good. Good, good, good. Let me make sure that, I can, like, everything else works. So, okay, continue statement, then we have an expression statement, which contains a function called to the function printf. Good. Good, 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 good. So, I can comment that out. Alright. So my code now supports the major statements, the major control flow statements. Yeah, so it controls break and it has break and continue. So nice. Now what? What the title of my video is actually about, not video, my live stream, is like making my parser support more expressions. And the thing is, right? I need to support more expressions. So, I mean my thing. I should add music here. I should like get Kevin MacLeod. Should I do that? Let me see here. Uh, Kevin MacLeod playlist. 1 hour, sure. Oh, but then I'd have to like credit like every single song in this video, like bro. And so that was Sneaky Snitch, by the way, by Kevin MacLeod. Thank you so much. Hopefully that verbal thing is good enough. But okay. Um. Uh. Whatever. I'll just sing like. No, that's gonna be like. None of the songs I know are like copyrighted. Okay. So should I support? Okay. What do I support? Okay. What do I do? I think I want to support assignment. An assignment expression. Right, let's support an assignment expression then. Where is an assignment? Okay, what do we do? So it's a binary expression, right? An assignment expression is like the largest kind of expression, right? So, yeah, an assignment expression is like, should I Google, like, should I copy? Okay, CPP reference, operator precedence. Yeah, the top one, oh wait, no, top one, oh no, comma operator. And then all the assignment operators. Yeah, yeah. Sorry, I feel like I'm plagiarizing C or C++. I'm so sorry. Oh well. God have mercy. Okay. Uh, we want an assignment expression, so I guess we'll do that. And so what kind of binary expression is this? Well, this is an assignment. And we'll set this to like high level, 20. And we'll just call it, hey, we want assignment. So token type equal, we'll give assignment. Expr assign. So we're gonna go and add that to the expressions. I feel like I should like separate this. There you go. Should there be an error token? I don't think that needs to be a thing. Okay, that's not gonna distract it here. So we want here. Yeah, okay, distracted. But yeah, so there should be an assignment operation now. So now that means what I can do is var I is equal to 0. I can like uncomment this. And increment can be I is equal to I plus 1. Okay, let's see. Let's see. So we got a for loop here, var decl statement, yes. And then we got an expression function call here. And what do we have here? Wait, no, wait, what? Should continue, yeah. It says it's a function call. Did I think I just forgot to change the name or something. What's the name again? Assignment. Yeah. Okay, no, this should be extra assign. There you go. So let's like save this and then run it. Here. So we have, okay, yeah, logical statements, right? And then we have an expression function call. And now we have an assignment. Right. And so, yeah, so we got an assignment, block statements, expression. Yeah, yeah. So we got an assignment, right? Yeah, that's nice. So if I do like, say, let's say I want to assign a character in a string. So if I do like string, oh wait, no, that's not gonna work. Um, anyways, so whatever. Right, so we have assignment now. That should be good. But if we do this, let's see what happens. Yeah, we have extra assign between an addition expression and another addition expression. Oh dear. Okay. Well, the left side should not be an addition expression. It should be an R value or I don't know. Okay. Either an identifier or a kind of reference expression. Like using brackets. But whatever. Okay. We'll just brackets as in square brackets. Okay, whatever. We'll just worry about that later. Let's just see. So that means we got assignment done. All right, let's get more efficient here. Okay, so we got assignment currently supported. Yeah, we got assignment, and now let's do comparison. Um, yeah, so comparison that's actually has a lower precedence than assignment, so it's not like as expansive as assignment. So we'll just do like these comparison. Did I say expression? I mean comparison. So okay, and they're binary expressions, so that's good. But they shouldn't be they should be purely binary. I think. Or maybe not. Let me check. Let me check the C++ operator precedence. Let's see what happens here. Okay. So, oh no, but these, okay, where are the comparison operators? Oh. For equality operators. Oh, so this one is a higher precedence than this one. Relational. So equality and relational operators, they have different precedences. What in the heck? That is, I mean, okay. What does that mean though? Should I implement the same thing for my language? Do I want to plagiarize C++? No. Okay, so I guess we'll just do like inequalities, man. Like we'll do yeah, I guess we'll do that. Okay, so this is gonna be a comparison operation. Wait, so uh do equality operators have the same precedence in Python as um relational operators? Or no? Oh, so they do. So it's not like C++. Okay, so that's my excuse for not treating them as separate levels. Okay, good. Comparison operation. So okay, let me first create the various expressions. So there's assignment, but then there's also the relational operation. So there should be a greater than. Whoops. Should be the less than as well. Um, there should be greater than or equal to, less than or equal to. Sorry. Okay. Now, what do we need? So, oh yeah, the equality as well, the equality operators. Equal, not equal. Should be, oh, whoops. Should have the correct names. Is this correct? Oh, whatever. I think it's probably good enough. Comparison there you go. So, yeah. It's going to be extra. Well, let's do like the equal. Oh, no, equal should be equal equal. What is this? Neck. What is this? Property neck? It's not. Oh. Wait, what? Why? It should be equal. Wait, what? Oh, it's not equal. It should be neck. Good. Okay, so, whoops. Whoa, 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 whoa. Here you go. So it's not equals. Now, we do, okay. Token type dot, what, greater comes, great. Less than. Okay, I'm expert less. Okay, expert less. I already have it. Don't I have it? Oh, okay, I misspelled it. I put it. Okay. Greater than or equal to, less than or equal to. Ah, miscapitalized it again. Yeah, so great less gak lek equal neck. Wait, that should be good. I think that should be good. So if I do, so this should continue. So I is less than Sterling, I guess. String. Something like that. Let's see. Okay, so for statement, we got a var close statement, expr less statement, not statement, yeah. So it's an expression and that's okay between an identifier and a function call. Yes, okay. Let's see. Okay, I think yeah, I misspelled it here. This one as well. Okay. That should be good enough. So these are the condition comparison expressions, and it's at level 10, yeah. Level 20. Okay. Now what do we want to do? So we got, okay, let me first update my comments. Binary. So we got, yeah, so we got all of these supported right now. Um, uh, okay, is that good? I'm not sure. Okay, no. Obviously, that's not good. Enough. Like, that, we need more stuff here. So, I think for a change, I think I want to maybe try to do pre-unary expressions. Maybe I would like to write some code for that. Okay, so, oops. Yeah. So I want to work on that. Okay, parse binary expression. So, because I have a function for parsing binary expressions, there should be a parse pre-unary expressions. Parse pre-unary expressions info. Yeah, so whatever. And then I don't think it would need arg1 though, would it? No, because it's pre-unary. We're not doing that. It's gonna return a branch. Okay. Now what? Okay, first we're gonna get token types, types from info. Okay, so now we're just gonna check, hey, do we have here a token? Okay. If this dot seek token dot kind. Okay, let's do up. Okay, so up token type is equal to this dot seek token type. There we go. So hey, okay, if this, okay, what's this? So if token types as token type, okay, yeah. If it includes this, then return. Okay. Hmm. No, we'll just do this dot parse expression. Wait, should it be? Wait, how does it parse the expression? Level -1. Okay, level -1. That should be good. All right, but if it is one of the operators we're searching for in this pre-unary expression, for a pre-unary expression, we're gonna try to what? Parse that expression. So we're gonna do this dot else, this dot next token, right? Right. Now what? We're gonna try to do there should be children though. Arg1. Yeah, I'll do children. Okay, let's not get distracted. I think. What do I even do? Okay, I need to push an expression. Just the parse expression what? Parse expra level -1. Okay, good. Now what do? We want to return this expression. So I don't think we should use this else. So that's needed. Okay. We want to return this. So we'll do like return this dot make branch. Okay, what are we gonna do? We do expert types. Okay, let's see let's see what's do here. Okay, expert types as token type array, right? No, it's not token type, it's branch type. So branch type array. And do wait, what? We have keys and we have values. Don't we use info? Yeah, you do info. Okay, info op token type as branch type. Content. Okay, there's no content, and we're just gonna put children. This should work, I think. Okay, let's just see the logic of this. So we have this. Okay, so we're asked to try to parse and see. Hey, do we have a pre-unary expression? Okay, so we first get the token types that were given, the expression types were given, the op token type. So we're gonna check. Hey, do we? Okay, let me put this at the top. Okay, do we have an actual unary operator here? If not, then we're going to just parse another expression that's not this, right? But that means, but if it is the operator, an operator that we're looking for, that is an unary operator, and it's pre-unary, then we're gonna do this on next token. So we're gonna eat that operator, and then we're gonna try to find an expression. Okay, that would work, but like, what if it's like of a level that is like the same as us, right? Like, I'm thinking maybe we should just do this. Hopefully this doesn't infinite loop. No, but it won't infinite. Well, it would infinite loop except if it has a maximum recursion limit, then it's not gonna do that. Yeah, cause yeah, right, whatever. Cause this is recursion right here. So right, so this dot parse expression level. Return this dot make branch. Token type as branch type. Okay, good. So let's see. Now let's try to actually implement this. So let's see. The not operator is this is the logical not. Where's logical not? Logical and logical unary. Oh no, because every unary operator I suppose has the same like thing, right? Prefix, yeah, everything that's yeah, logical not. See, it's the same. And it's lower, whoops. It's lower than okay, so this is just basically every pre-unary operator, and it doesn't really have precedence because it's unary. Okay, I guess that makes kind of sense. Yeah, that makes some sense. All right, let's see. So this is a what is this? This is a parse statement. We do not want that. We want parse func deco parse file. Where's parse expr? Parse expr. Where do I define it? There it is. Okay, good. Okay, I might have to wrap. Yeah. Okay, so it's 10 o'clock now. All right, I guess I'll wrap this up. Actually, not. Okay. Should I like try to continue it? Like, okay. Or should I just leave it to tomorrow? Because, okay, so we have parse expression. Because what I need to do is just implement it. Just put it here. So, addition and subtraction. Okay, multiplication and division. It's brackets. Should we do... Okay, I don't think it matters. Is it parse expert value? I feel like this should be else if feel like this. Should be like this. Okay. Brackets. I think it should be okay. If it's 2 is multiplication or division. Okay, what if, okay, we'll check for unary operators here. Pre-unary operators, that is. Okay. So, no, well, okay, if it's not brackets, then it's, either, okay, I'll do else if. But how do we know whether it's an unary operator or not? That's why we use levels. Okay, I'll, just postfix. I feel like I should just plagiarize C. The 4, I need to make sure I change that. 5, 5. Okay, it should be greater than or equal to 1. Level is greater than or equal to 3. Getting distracted. Pointer to member. What is that? A dot. Oh my gosh, that seems really I guess we're plagiarizing in C++. Okay, wait, is C++ a copyrighted language? Is C++ a copyrighted language? Under international legal precedents, a programming language is considered an open specification or a set of ideas, and ideas cannot be copyrighted. However, intellectual property rights do apply to specific materials related to C++, which are broken down below. Yeah, so the ISO standard documents, okay. Compilers and tool chains, standard libraries, was the syntax and keywords. Oh, that's nice. I can literally just not do, okay, good. I will use my rights under the Canadian Charter of Rights and Freedoms. And we'll just like do that. Okay. The pre-unary operators. Return this dot parse binary expression. This dot parse binary. No, this dot parse. Well, this dot parse pre-unary expressions. I was gonna say, hey, we want what do we want here? Well, we want what we want is a token type dot star. Not star. What am I doing? Parse expression. Okay, we want a plus. So if it's a plus, then it's gonna be branch type dot extra positive. Um, extra negative, not neck though. Minus. We'll take care of that later. And then the next one is the level, which is gonna be 3. We'll just say it's 3. And now we'll just set, and then we'll also set not as well. So not is extra not. Extra positive negative. Okay, Oh yeah, not. There you go. Okay, so hopefully, if I do, that is not, okay, if I do not equal like this, hopefully this should work. Okay, so let's see. Here's a function declaration. Block statement, here's a for statement. Var decla statement, good. Good. Then we've got an x for not. X for equal. X for ident. Yeah, good. If I do not plus negative, do that. See what happens. Okay. So, for statement, var decla statement, x for not, x for pause, x for neg. So it's negative. That should be good. Okay. For equal. Yeah. So that should be good. Yeah. All right. So we got our pre-unary operations done. So, pre-unary. Yeah. So pre-unary not and pre-unary plus, pre-unary minus are supported. Um. Hmm. Should I support the comma operator? I don't think we need to do that yet. That's pretty advanced. Um, Suffix, postfix, increment. Yeah, so these are postfix operations. Uh, hmm. Yeah, so what if I create a kind of post-unary function? Um, no, okay, function call. So, how about, okay, yeah, so this is not it. I'm gonna get rid of these comments because it's not needed. Comma, make branch. Okay, how about I get rid of this? I'll just comment this out. And I'm going to try to do a function call. So this is pre-unary statement. So we'll do following C plus plus. Okay, gonna be post-unary operators. If this dot seek token dot kind is equal to, wait, let me just copy from this. I'm just gonna copy this code right here. I'm gonna get rid of this else. Right, if it's a post-unary operation, then if it is a function call, if it is, okay, first of all, for post-unary operators, should I put this in a function, that kind of, because this seems to be, I don't want this to be repetitive. I want my code to be repetitive. Okay, how about I just forget about function calling for now? Not forget, but I'll just lay it aside for now. I will just create the post-unary expression function that kind of just wraps it. To do function call. Yeah, I think that'll be a better idea. So, yeah, I can just put it in the post-unary function call, whatever. Okay, this is pre-unary. We want to do post-unary, so I think we do that. Okay. Function. Okay, I'll just copy this over. Okay. Okay. So children, I'll just put it here. Token types. Okay, here we're gonna do this. This one we'll do later. So I'll do let expra be equal to what? Just dot parse expression. We're gonna try to parse an expression first that is below this level. And then, okay. Yeah, and we just do that. And then and then we're gonna see, okay, I'm gonna check that token, right? So if op token type, if it's not the case that, okay, let me just copy the code here, and I'll just do this. And we're just gonna return expression. Right, but if it is indeed the case that we have a post-unary operator right here, then we're just gonna say, hey, what? Oh yeah, we're just gonna create a new token. So return, oh wait, no, this dot next token, first of all. We're gonna eat the operator token, and then we just return this dot next, not there, this dot make branch, okay, what else? Okay, branch type, so info, op token type as branch type, and then content is nothing. The children will be expression. We'll just do that. Let's put it in an array. Alright, that should be good. Okay, what else do we need? I want to see if this works. Although, first of all, I didn't even apply this yet. So we need to do post-unary operation. What do we do here? What do we do? So we're gonna do this. We're gonna do parse post-unary operators. So what are some post-unary operators? Maybe like, okay, there's plus plus. Okay, we might as well do plus plus and minus minus. So okay, so we're gonna get rid of this. Plus plus. We'll do d plus double minus. Should I do, okay, post increment. Wait, no, this is post decrement, decrement, post increment. So we're gonna go to branch type, we're gonna do that. So expra, um, okay, post increment, this would be decrement. And then we're gonna go to tokens, and we're gonna say plus plus minus minus. But we need to add the code for that as well. So d plus, d minus. Um, okay. So if C is already eaten, right? Just not next char, yeah. So if this dot seek char, wait, am I doing this correctly? If this dot seek char, yeah, is equal to if this dot seek char is equal to what? Another plus, then we're gonna do this dot add new token. We're gonna first eat that char, and then we add a new token, and say it's a double plus C plus. Well, it's not. Whoa. Wait, why is this not working? I have D plus here though. Oh, D plus. No. Okay. Now we got this, and we gotta do an else statement, I guess. Let's see, and then we'll do. Whatever. Those are bugs, but I don't think that really matters. Okay. Whatever. So we got here, minus, C is equal to minus, this dot seek char minus, okay, this dot next char. Add new token D minus, else, okay, this, okay, good. Okay, I think that should be good. Okay, now we actually go to token type dot D minus. Let's see where it's referenced. Here. There you go. So this function call thing, we'll take care of that later. But now, we'll just see if I++ works. This is a post increment. Get rid of printf, and this function call as well. I'm not gonna do that. Okay. Let's see if this works. Maximum call stack size exceeded. I see. So something's wrong with the post expression. So, oh, should be true. There you go, fixed it. Okay, so let's see. Let's see what's outputted. So it should be a var decla statement. Okay, good. So there's a for statement. Okay, there's a variable declaration statement, and then whoops, um, an NEQ statement. So not equal statement, not statement expression, and then we got should be a post increment. Yes. So it's working. If I do like this, it should be like you do the post increment first and then you do the not. Yeah, yeah, good. If I do this, this should say unexpected. Yeah, expected int, but got D plus, yeah. But what we can do is, okay, we got post increment. We can use pre increment as well. So pre, okay, okay, no, it's because I'm not, okay. Here, post, yeah, pre-unary, yeah, so it's a pre-unary thing. It's gonna be pre-increment, pre-decrement, okay. Okay, let's see. So here, variable declaration, okay. So pre-decrement of what? Pre-increment of what? Of the post-increment of x for ident. Good, good. God be praised. All right, let's continue. So we have that. Now we actually want function calls, right? So yeah, so now we support post-unary. We got plus plus, plus plus, minus minus. But now I want to add function calls to this post-unary. So okay, praise. It's working, man. You know, like I've tried several times to make something like this, and the only other time that I was like successful at doing this was like year I think one or two. I think it's only like one or two times that I've been like successful in like making a parser that's like able to do these things. Because like I remember, okay, a few years ago, like I tried to make these kinds of like custom programming language parsers, but then like kind of failed again and again and again. Well, okay. Yeah, but then eventually I think I made something in C++. I think it's on this channel. Yeah. I remember like yeah. Yeah. I think I watched myself like recently I think I looked at my one of my oldest videos on this channel um where I was trying to make like a function thing. What's it called? An assembler, not a compiler, I guess, for my custom programming language, which I called HTAC, I think. Um, Whatever. But that was in C++. But here I'm doing it in TypeScript. And okay, let's not be out of hand here. So let's do like to do semi or statement. What is that? Yeah, I already do that already. Okay. Semi or statement. Yeah, because it's a semicolon or is it our parent. Okay, expect semicolon to conclude function declaration or a function body or a statement as the function's body. As a function body. What should I name it? Okay, whatever. So we have that. Whatever. Okay, so I wanted to go, okay, to do function call, right? So I think I can just like, insert this code in parse unary expression. Of course, I have to edit it a little bit. Yeah. So I'll do what's this called? So this is post. Yeah, this is post unary expression. Wait, no, but if it's not gonna, if it doesn't include it, right? Then okay, there's a possibility that it's a function call, and that's what happens is okay, the op token type is a left parenthesis, right? But if it isn't, right, we're just gonna do else return expression. Of course, that's not necessary because there's a return statement here, but still. Okay, so let children res.content. Oh, no. There's not going to be a function name. It's literally just going to be the expression. Right. Okay, and I'll just do like children.pushback. Okay, no, I'll just put it here. Expert. There you go. That's going to be the expression that's like called with this, by this like thing. Res is equal to this.seek token. Okay, now I'll just define, okay, let res as bool. Okay, I think I should just put it here because this is where I actually use it. So let res be a token type and bool be a boolean. Not token type, just token. L parent, okay. Argument. Okay. Comma. Error branch. Okay. Next token. Okay, let's see. Let's cook right here. Oh, function name. It's not gonna be a function name. It's literally just fire. Okay. So that means then that if I what is this? This is a function call and we're not doing this. So if I try to call print, this should work now. Let's see. So we have four, okay, we have four expression var jackal, okay, 0. If I is not equal to 5, then we do pre-increment I. And then now we have a block statement where we have an expression statement and we've got a function call. We've got an expression identifier, right? And then we got arguments, these are arguments. That's cool, that's cool. So that means I can theoretically just call the string variable. We'll add 10 to that. Yeah, this is very not secure. Yeah, so not equals, yeah, good. Pre-increment, okay, yeah, we're pre-incrementing I there. Now we have block statements. Now we have an expression statement here. Wait, no, expression statement, which is this big thing right here. And so it's a function call where it has, on the left side, it has an addition between string and integers. There's no separate type of expression for blocks, for braces, I mean brackets or parentheses. Groupings, it's just like a regrouping thing. So I think that's more efficient, right? I'll be arrogant. Okay, so we got this is a parameter, an argument that is, in this case, because I'm calling the function, I don't know. Because it's an no, argument, there you go, and then a an identifier. Okay, good. Good, that's the other argument. That's good, good. I do this, if I like make some sort of error. Unexpected semi, but got L stra. Oh, there you go. Well, do I want to make better error messages? Did I try? No. I'm getting distracted. So it is working. It's working its way there. It's good. So it is working. Post unary. Yeah. And now I think I want to do brackets as well. That's not okay. Yeah, I think I want to do brackets as well. And what is that? And C++ calls it a subscript. I would like to just call it an array index. So no, well, just an index. Yeah. So we have brackets though, right? Lbrack. Do we have lbrack? Don't have lbrack. Oh, lbrack. Rbrack. Lbrack. And we got rbrack. Very good. We have the left bracket and the right bracket. That should be good. Right. Now, function call, or it's an index status, else if. Else if. Yeah, so I feel like this res and children should be here. There we go. If else if it's an rbrack, lbrack. Index. So extra function call. I think I want to call this extra index. Pre-increment. Post-increment. Yeah. Okay. Extra index. Here. So I guess I'll just oh, I think this should have a semicolon because I want it to have a semicolon. Okay. Now we want to do this dot seek token, this dot next token. Now this is gonna be an lbrack. It should be lbrack, not lbrace. Okay, and now we do res kind is equal to this dot next token expect type token expect token type dot rbrack. Not kind, okay, bool. If not bool, we're gonna do return return what? This dot make error branch. Alright, we're going to return this dot make branch type extra index. Oh wait, no, that's children though. Okay, never mind. That's fine. Children. I'm gonna do children dot push back. Okay. Children dot push what? Expression, the left hand side. And the bracket so. Wait, but why? Oh no, because children already has express. Okay, so we don't need to do that. Okay. Now we just need to do children dot. I don't know. Okay, children dot push. What do we append to this array or this? No, this is not Python. This array. Sorry. Is this dot parse expression? We can parse any expression. Yeah, because it's in groups, right? A bracket. So yeah. Okay. I wonder, how useful are comma expressions? The few niche situations. Oh, cool. Preprocessor macros. Okay. Yeah, that makes sense. Okay. Interesting. Okay. And I'm getting distracted again. Ha ha ha. Okay. So, well, that's nice. So we want to index this. So, now our brackets. Okay. Left bracket. Wait, why is it R bracket? Oh, this is out of order. Maybe this one. Parse expression. This is gonna be arguments. Okay. Put in the brackets. And then we do R bracket. Okay, and then we just do that. So now we can kind of print out a character. If we say, hey, okay, we could do, I'm gonna comment this out, printf. Let's just do like string I is not equal to null character, so that's hex OO. Printf character in string. Okay. D character number, say, okay, that's fine, D. In string is we're gonna do C. Okay, and then what do we have here? A character, okay. That's gonna be I plus 1, I guess. And then string I. Let's see if this works. Okay, no errors. Okay, good, good. We have main, okay, 4, okay, var I 0, I equals 0. I is not, okay, so not equals what? So we index string I, okay, good, good, good. Yeah, okay, this is char. We increment I, and then we have a block statement where we have an expression statement. It is an expression function call, so it's a function call. Printf, and it this is the string first argument. The second argument is an addition between I and 1. The index string and identifier. Okay, so now there's an index to the string. Identifier. Okay, good, 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 good. Things are working. Praise be to God. Okay. Now what do we even do? Well, we'll go here. I feel like I should like comment this out. So what do we have here? So we have post unary. Yeah. Now this is supported already. And we also got post unary. We got this one. There you go. Should we do comma operator? Like, should we really like? I mean, why not? But here's the thing, right? What if like I'm trying to find? What if like for a function we don't want a comma? Well, okay. Comma operator is lowest, so we're gonna go to parse extra. Okay, we're gonna add comma. So symbols, oh yeah, we're gonna have the comma among token types. We just want comma here. So do extra comma. Is C programming language copyrighted? Nope. Ha 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 ha. There you go. Okay, that's fine. Why am I so like law-abiding citizen? Okay, okay, now we want to do that. So, alright, what do we want to do? Okay, we'll do parse extra level. I guess you could set it to like, this is arg1. Should I do like, okay, what should comma be? I'll set it to like 21, 64. Yeah, I don't know if that's gonna work. Okay, so, I don't know, because I don't know. I don't know, because I don't know. Okay, comma operator. So else if, so okay, level is greater than or equal to, let's just set it to like 32. Return this dot level, okay, return this dot parse, what, binary expression? Yeah, binary expression. What do we want here? Token type dot, comma, results in a branch type dot extra comma. And so yeah, so we have a comma expression and it's just, okay, level 32. And yeah, we can pass argument 1 if we want. Let me make sure that this works still. Okay, good. But here's the thing, right? Now, when we try to do function call, where is the function call? Wait, no, let me show this here. Here, we have, okay, comma, yeah, we have a comma operation here, and we don't want that. Extra function call, extra ident, yeah. So we don't want that. So I think I have to set it to 31. So extra func call, set it to 31. Set the level to like 31 or something. Yeah. So we want to do a parse expression, and we'll set the level to 31. Because that's the level below comma. Let's see what happens. So we have expression statement. Okay, block statement, expression statement, function call, printf. Yeah. So we just have this. But we can, if we want to, we can do like do this, and then we'll do a minus minus hello. Like in that example from ChatGPT. Thank you so much. Okay, let's see. So let's see. So let's go back to the for statements. We have a variable declaration here. So okay, good. Now we have not equal not equal expression. Okay, good. And now we have a comma expression between what? Pre-increment I and pre-decrement hello. Yes. So okay, let's not plagiarize AI here. Okay, so that's good. Good. Okay, so any, okay, it's not even, it's not, it's a binary operation, so. Okay, should I do more of this? Yeah, so this one is done. We did that. Yeah, let's add some of these ands and or. So, ampersands. So, yeah. This one is also preliminary. Okay, so we'll do binary. Okay, well, okay, let's add some more tokens. Let's go to post. Okay, where is, oh, whoops. Okay, let's make them tokens. So, let's go to token types. So we want ampersands, ors, yeah, stuff like that. Okay, let's do that. Amp, well, it's and, I guess, and there's a double and, and then it's or and door. Um, I mean, it is just pipe. I feel like I should just call it the name of that symbol. Good. Okay, so we have some of these. I feel like I should add. What else does it need though? Pipe. Okay, so we have shift left and shift right. So I think we should call it like deck. D-lec? No, D-less. Less and greater. Yeah. And we also have that caret. Um, is there like a double caret? Like, okay. Is there a double caret or not bitwise? Okay, is there. Why does C not have bitwise XOR? No, no, logical XOR. Oh, the inequality operator already acts as a logical XOR. Okay, that makes sense. I'm getting distracted. So, well, kind of. Kind of. If you like logicalize each thing. But whatever. We'll have caret as well. So caret. So we have a laundry list of things that we gotta, you know, do here. So let's start with D less and D greater. So what is D less and D greater? Okay, so we'll go to wherever this is referenced. Right, we got this one. We're going to do else if it's a less than, right? And we're going to call it D less. Um, whatever, I don't want to edit the comments. Oh dear. Okay, seek char. Okay, so if it is a, not an equal sign, but a greater sign, right? Add new token. D greater. So, okay, we got those two. I think that should work. So now that we have those two, so D greater, now we want to do amp. So here, case C is equal to N, right? That's percent sign. Oh, percent sign. Do we need percent sign? Oh yeah, that's modulo. Yeah, we might as well add that as well. This dot add new token. Token. Okay. Token type dot percent C. Percent is equal to percent. There you go. And then now I just need to yeah, percent. Okay, what else? So you want ampersand. Now what do we do? Okay, we'll do, okay, this dot seek char. If it is another ampersand, then we're gonna do, okay, this dot next char. But we're gonna add new token as double ampersand. Okay, and then I'll do else. Alright, now I just need to do the same thing for or, for the pipe that is. And then lastly for the caret as well. I think that's all. Wait, okay, is that everything that I need to, okay, let's not leak our code here. Code base, okay, d plus, okay, b less, yeah. Yeah, so, now I want to add those bitwise operators. Okay, let's see if it still works. Right, now I'll just see if this works. So, do this, do that, do this, do that, do this, do that. Um, um, what else? This one, um, this one, this one, uh, what else is there? One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 6, 7, 8. Okay, good. Okay, let's see. Let's get the errors. Expect, okay, we got D less. Okay, good. D pipe, D amp, amp, caret, percent, pipe, D greater. Okay, good, good. So now what do I do? I want to like create a parse. Oh, here you go. So let's do some of this. So how did see? Should we do the ternary conditional? I mean, why? Oh dear. Um. Okay. So first of all, after addition, there we got bitwise. What is three-way comparison? What? What? Yo, that's cool. Okay, let's not get distracted here. So we want to have bitwise left shift and right shift after addition, like above addition and subtraction. So we're just gonna copy this and I'm gonna paste that here. Okay. Bitwise shift, bit shift. If it's a double, what? Double less or okay, double greater. So less is gonna be a extra B shift L. Yeah. Then here B shift R. Okay. Expra B shift L. B shift R. What the heck? Task, did I just, oh, what is this? Task Manager Google Chrome. Oh, I accidentally opened this. Okay, so we have bit shift. So this should work. So if we do I is equal to I bit shift. Okay. What language does not support? What programming language does not support plus equals? Okay. R, Go, and Scratch. Okay, that's Scratch. Go. Interesting. R. Right, I'm getting distracted. So, okay, whatever. So if we do this, would this work? Shoot. What the heck? Expected R parent that got minus. What did I just do? Expected R line 4. Instead, expected R parent but got minus. Um, okay. Fix it. Okay. So it says here, okay. So before this, we got an expression pre-increment. Expression statement, we got a function call. Okay. Good. We're just gonna hope that this compiles correctly. Expected semi, but got damp. Oh. Uh. Oh, because I didn't implement and yet. This is not gonna make sense, but okay, actually, well, well, I mean, it doesn't do anything because it's already 0. Okay, so it says here, pre-increment here. So we got, not equals, yeah, this one index, and then, we're indexing this thing right there. Okay, bit shift left. Okay, good. Okay, good. And here we got, an assignment in I, and then here, bit shift right? Bit shift R, yes. Okay, that's working. So we got bit shift. Um, okay, good. Now what do we want to support? We don't have tilde yet. Should I do that really quickly? Yeah, we'll add the tilde. So token type tilde, however you say it. Okay. Okay. So we're gonna go percent. Tilde. So this is gonna be tilde. Good. Alright, so now this is tilde. Gonna make sure that this is correct. Yeah, it looks good enough. So we know that okay, this language supports this bit shift now. Okay, good. Now we want to support the other things. So let's see. Which one is first though? Should we do, okay, so comparison is first, and then we get bitwise AND. Okay. Should be else. Should be bitwise AND first. Okay. Okay. Does Python um have special operator precedence between different bitwise operations? And XOR then OR. Okay. Okay. Bit shifts. Okay, oh, you know, this should be, and, no, what's it called? Amp. Just 1 amp. Okay. 1 amp. Yeah, okay. So you do the logical things first. Not logical, the bitwise things first. So, okay, expra band. Okay, let me first do that. So, bit shift, wait, so is bit shifting is first? Yeah. And then you do these things right here, including this, and then we do AND here. So, expra AND, no, band, expra band, bor, and then you got binary XOR. And then bor. Okay, no. Bor is after binary XOR. And then we get logical AND, so that's X for AND. We do land. Not really. And X for AND. Um, or. That's that, right? And then or. Okay, good. So now we can actually go here, and we're gonna go here. Okay. So this is band. And then this should be 11. Yeah, so I need to remember to change those. Nope. Do this, I guess. And so this is gonna be bitwise XOR. It's gonna be 12. So this is caret, right? And this is the expra XOR. No, B XOR. There you go. Now we change the level 13, 13. This is bitwise, not bitwise anymore. This is logical. So AND operation. Logical. And what? Oh, damp. And 14, 14. This is gonna be logical OR, right? See. Yeah, it's just that I don't have like this one of the extra things. Okay. Yeah, and XOR or then and or. And XOR and XOR. Wait, where's bitwise? Oh shoot. Okay, this would be 15. Oh, this is gonna be a pain. 15, 15, 15, 15. Um Wait, no, it's 13. Oh no, it should be 14. No, this is 15. This is 15 and then this becomes 14. Yeah. But then, yeah, and I gotta remember, yeah, so this is bitwise XOR. Now there's gonna be bitwise OR. Be 13, 13, pipe, OR. Uh, bitwise OR, okay, bitwise logical AND. What else does it need? Okay, so it has, we have BXOR, we have BOR, BXOR, BOR, we have AND, okay, logical AND now. So that's correct, right? Bitwise AND, bitwise XOR, bitwise OR, logical AND, logical OR. So bitwise AND, yes. Bitwise O XOR, yes. And then bitwise OR, yes. Then bitwise, no, logical AND. Okay. Logical AND, and, okay. Be logical OR, but I did not finish writing this. So this should be door, no, D pipe, double pipe, and this should be OR. There you go. So, and, OR, logical OR, we got assignments. Now we got these, yeah, these are various assignments. We also got the ternary conditional. Do we want to do a ternary conditional? No, I think what we want to do is to first, like, test this out, see if this is, correct. Or, and, let's make sure that this still works. Okay, good. One. So if we do, let's see, let's make an expression here. Let's make up an expression. That should have the correct precedence. So this should be OR. Let's do A, okay, let's do A, B. Right, and then let's do AND. And then let's do OR, bitwise. And then let's do bitwise XOR. And we'll do bitwise AND. Okay. It is going to be a pain, but we'll see how it's going to do its thing. It doesn't have to be the most efficient, because, whatever. Because it'll still just run in a separate thread on Roblox, on the web. So that's fine. Right, let's see. Right, let's see the thing. So we got an OR, and we got an and we should have a BOR. We got a BX OR, good. Band, yes. bond. Okay, good. Good, this should be good. And I set it to like, who is this? So if I do this, we have assignment, and then we have identifier, and then we have an or between uh this one, or, and then and, yeah. So that should be good. And we can continue running things the same as before. So now we have a hefty little thing here, right? Yeah, it's pretty you know, it's not featureful obviously. It's it doesn't, it doesn't produce code. Um that's one thing to note. Wait, let me check my oldest, or one of my oldest, not my oldest video. My oldest public video as of now is the um like oldest currently public video. I mean, as of right now is my snake game, I think. Let me go to my oldest. Yeah, no, it's Fizzbuzz apparently. Okay, here you go. There's making a code generator. Yeah, that's snake game. I think I privated that. Yeah, but yeah, I have a video. Well, yeah, so I'm making this H tag line. So wait, let me show the um there you go. Yeah.
Hello.
So in this video I use this program, made the music, this one. Apparently, okay, okay. In this video, I'll try to make a code generator for my made-up programming language. See, so here, I was making a code generator. So I got really far by just using C++, and wow, I have like way less lines in this. Oh wait, never mind. This is just the top part of the function. Okay, this is the top bit of the code or something. But yeah. Expected error. Ah, okay, that's cool, that's cool. Alright then, cool. I'm getting distracted, but okay. So yeah, so I got a little bit far on that. And I still have the code actually. I just need to, I don't want to revisit it though, because it's like, it's gonna take some time to like actually try to understand my code again. So like, nah. Okay, so now, what do we have now? Well, we have these things, right? We have these operations. These operations we support now, and these are binary operations, and these are after. There you go. And then we also have pre-unary, and I want to do that. So, what are those? Token types. No, not token types. Branch types. And that's a pre-unary operation. So, operation. Okay. Okay. Index. Okay, this one. Expra pre. Expra. What's it called? B naught. So this is bitwise naught. And then we also got extra. What else do we have? Extra. What's it called? Address. So okay, extra adder. I'm thinking of this in reverse. So there's gonna be in first in my head because I was thinking of the star operator, uh, which is the not address but the reference operator, I think. Indirection, dereference. There you go. Indirection. So we'll just call it reference. empty extra ref. Okay. B not. Yeah. So now we want to do that. So now we want to go to, okay, pre-increment. Let's do token type. So token, should I just, instead of D plus, we have D, oh wait, no, I forgot. Oh no, okay. This is a pre-unary. Okay, good. We want B not. Extra, no, token type, tilde. Extra B not. And then we got the star is extra ref. And what else do we have? Slash, no, that's division. Okay. The ampersand. So and token types and. Oh no, amp. There you go. And the expression, and the name of the expression is address. So okay. Okay. What do we do now? Um uh hmm. Because now we can do something like printf address of main function is do there you go. Printf what do we do? Address, yes, that's the address of the main function. And then we do address of what? Hmm. Okay, we'll just, how about this? Another function we call, how about we call this? Something like that. And then we also just do b naught of, we don't support hexadecimal here, so 255. Well, let's do 127. So not 127. I don't know how many bits that's gonna be, but whatever. Whatever. How many bits 127 is gonna be, as in like that data type for that. I think this is gonna be like 64-bit or 32-bit integer, whatever. Okay, whatever. Now we want to do that. So let's see. No errors so far. Okay. So function declaration here. Main argc so we got a block statement. Right, we got an expression statement, and it's a function call of printf, is the function expression. And then address of the main function, now it says address, right? Expression, so here, extra adder. Yeah, that's what we want. And then, so that's good. And then we got expression statements. Extra function call, we have a function call of what? What's the function expression? It's a extra reference. Extra address, right? Address of another function. Okay, extra indent. Actually no, because then doing that, if that's okay, whatever. We'll edit the. We'll think about what this actually means in when we actually make the code generator. But whatever. Okay, so that's the identifier. All right. What else? So the last one is expression. The function calls it's calling the printf function, and then okay, string argument, and then okay, there's a binary not of the integer, literal integer 127. I feel like I want to support hexadecimal, but whatever. You can always just write numbers in decimal anyway, so whatever. So that should be good. That should be a good code generator. Um, Not code generator. That should be good for this. So that means we do support the pre-unary functions here, not functions, operators. So we basically just like support everything now, right? We're now basically just ready for a code generator. Either that, or we're gonna verify first of all with an abstract syntax tree. Yeah, we're gonna verify the abstract syntax tree, or we could just do that while um doing the. I mean, we could just try to verify the validity of the abstract syntax tree, like whether the nodes are like valid um in the code generator. Although, okay, I guess we'll just create a really quick function for verifying abstract syntax tree. But yeah, God be praised that this is basically finished. Well, not finished, but like for a minimum viable product. Um, so I guess I would like to create a new function that's going to be AST verifier. So token verifier here. So we got these things. It's just that instead of tokens, it's gonna be tree. So that's gonna be a branch. How are we gonna verify this though? How about we don't do the ASD verifier? Like I don't want to do that. I just want to do the code generator now. Okay, let's first comment out this code. Now I want to make sure that this is portable to Lua. So I'll just copy this code, paste it into Lua. Okay, now I'll just edit the library functions here. Library functions. Yeah, because they need some conversions. So that it's good for Lua, for Roblox TypeScript to convert it to Lua. Uh, okay, that's here. Yes. Okay. This is humongous. Okay, we got 1,672 lines of code. Now I'm gonna open Roblox Studio. Oh gosh. Right, let's not accidentally leak our things. Okay, so I have Roblox here. Right, so I have, let me just get this window here. There you go. Now what I'm going to do is I'm going to copy this code. I'm going to paste it over to this window over here. There you go. Then we're just going to like save. I'm going to take this back and put this back here. How do I like put it in here? I don't know. I'll just open the script again. Starter player scripts. There you go. Now I just need to like run it. Okay, let's see. Hopefully audio ain't lagging for you guys. Yeah, I'll just okay. Okay, there's extra function call, extra ident, printf. Is it pretty much, is it the same output as this one? Let's see. Yeah, 1630, 1630. Yeah. 1628. What is 1628? It says 28 though. Line 16, column is 28. Why does it say column is 28 when it should be 22? We have B naught of 27. That's column 22. Oh, the column is different for some reason. It's probably some like, it's probably because it's like trying to convert from like the line things because like Lua 1 indexes rather than 0 indexes. Maybe something's wrong with that. Hopefully that doesn't make anything. Anyhow, we could just disregard the column thing. We can just say it's the line because it seems like that's not. Okay, let me just important note. Luau compatibility function. So yeah, because this I want to use this for Roblox. So yeah. Alright, so important note for Roblox TypeScript compatibility. No, I don't want that. I want to put, what is this called? Oh yeah. Disregard column number and Lua and Luau port because it seems broken. Whatever. Alright. So now I'm basically just ready for an actual like code like thing. Okay, let me make sure. Let me get rid of this. Make the code. What kind of thing? What I forgot what it's called. Code what's it called? Code generator. There you go. Let's Google something about code generator. No, code generator compiler. Compiler design. There you go. Code generation is part of the process chain of a compiler in which an intermediate representation of source code is converted into a form, machine code, that the target system can readily execute. Yeah, parse tree or an abstract syntax tree. I don't see what's the difference between that. I don't know. The tree is converted into a linear sequence of instructions, usually in an intermediate language, such as 3 address code. What is that? Yeah. Presentation, people, optimization. I'm getting distracted, I'm sorry. Okay. So first of all, I need to like now actually think, okay, how will the assembly be? How will the assembly look like? Now I'm thinking I want to make it, so let me create a new JS fiddle. But wait, no. What we want is, okay. How about this? I think I should decide on what the assembly should look like, the assembler language should look like. So, example assembler language. Like for example, like okay, so should it be like, yeah, should it be like start, right? This is gonna be start. So ret what do we do? Like push EAX, push DX, something like that. Well, we're not gonna try to do some Intel i386 standard calling procedure. We're not gonna do that because that's not like that's not what we want, right? Because this is supposed to compile into like a virtual machine code type of thing. So, right. So before I do any of this assembler language, I first need to create a virtual computer. So, all right, let me create a new JS fiddle then. Nope. So yeah, I'm gonna create a new JS fiddle and I'm gonna say that it should be TypeScript. Right, thank you. I'll just okay, so the console should be great. Get rid of the adverts. Okay, I do not all these advertisements in this video I do not condone. That's just how it is, okay. Alright. But yeah. So what we want is a kind of okay, let me copy and paste my notes too. My notes here. Important note for Roblox TypeScript. Compatibility. Soli Deo Gloria. There you go. Alright, luau compatibility functions now. I'm just gonna copy this whole library of sorts. Library. Oh my gosh, I'm so sorry. Okay, there you go. So now what we want is we want a computer architecture and so a computer okay. Oh dear, this is getting involved. Getting really involved. We want to decide on the computer architecture now, like what the heck? Like bro, this is like okay. Is x86 compiler not compiled copyrighted? Okay, there we go. Instruction set architecture. Instruction set architecture. Copyrighted. There you go. The core x86 instruction set architecture is not copyrighted as an abstract concept or language cannot be copyrighted. However, creating a functional x86 processor is extremely difficult. No, we don't want to create a copyrighted. And can I make a virtual machine? Can I make my own ISA based on it? Oh dear. The instruction set architecture. Okay, well, okay, so we're just not gonna do int. Okay, okay, we're not gonna try to do that. But okay, so what do we want? So what does the computer have? Okay, this is back to like a high school course that I did back in grade 9. What does the computer have? Um, okay, okay, computer architecture. Um, I mean, okay, so you got CPU, RAM. What else does it have? It should have a ROM, I think. Um, how should this virtual machine work? CPU, RAM, ROM. What else does it have? It should have like I/O ports as well. What's this called I/O? Oh, ports, whatever. CPU, RAM, ROM. Okay, parts of a computer. I think okay. I think I forgot the GPU. Oh yeah, so the motherboard, storage. Yeah, GPU. Okay, GPU. Um. Uh. Perm storage. Yeah, so you have a GPU, and I guess it's just called a V card. We'll call it a V card. Oh, never mind. V card means something else. Okay. Okay. This is not. This is stack trace. This is not what I want. Yeah, okay. This is okay. Yeah, this is an old version of my code. Okay. Okay. So we want CPU, RAM, ROM, I/O ports, DPU, permanent storage, peripherals as well. So I/O ports, perif. Peripheral. Should we do peripheral? GPU. Okay, peripherals. There you go. GPU, perm storage, things like that. Alright, so oh dear, now we're making this is getting involved, man. Okay, what will the CPU be? Um, because this is gonna be based on Lua, which uses numbers, which uses 64-bit floating point decimal numbers. I think we're gonna make it 32-bit or 64-bit thing. I don't know, man. We'll see. Um, but that means like each byte, each bit of not bit, each like not segment, but each like indivisible unit of memory is gonna be 64 bits long, and we want to like make the most of that, right? Um, I'd argue. So, I think what we're gonna do is we're gonna have 64-bit instructions. So 64, it's a 64-bit thing. So 64-bit instruction set. And now, so what do we want here? Well, we want the instructions, I guess we could like start with hexadecimal. Oh, yeah, we'll do that. So these are the topmost bits. But how are we gonna do that if we have to use this one? Okay, so let me check. So would they convert it to one? Would they convert it? Yeah, so they would convert it to that. What does bit 32 do? Lua bit 32. Bit 32. Um, this library provides bitwise operations. It provides all its functions inside the table bit 32, unless otherwise statement. All functions accept numeric arguments in the range. Okay. Each argument is normalized to the remainder of its division. Okay, and truncated to an integer in some unspecified way, so that its final value falls within the range of this one. Okay. Similarly, all results are in the range. Okay. Note that B not. Okay, yeah, which is different from. Okay, that's true. I feel like we gotta make this within Roblox TypeScript itself. We can't run it though. Um, hmm. Let's see. Okay, what if I run? So if we do not 1, I think? Not 0. Console.log. Wait, dot to string to precision? No. Number.hex. Display number in hexadecimal JavaScript. It's a number.prototype to string. Oh, you did toString. Okay, radix. Radix is the base? Oh. ToString and then 16. Yeah, because that's not. So we want a function. Okay, that's not it. Yeah. So that's definitely not the same behavior across these libraries. Is there like a bit32 library? Okay, TypeScript, bit32, okay, TypeScript library that has the same functions as Lua bit32. Okay. How to work with 32-bit integers JavaScript. How do you do that? You bitwise or with 0. Okay. So I'll just do something like, okay, const, oh yeah, because I already have some of these functions, right? I have it in my library. So luau, okay, bit32. Okay, let's look at the 4 functions here. We have R shift. What's AR? What is AR shift? Arithmetic shift. Sorry. Vacant bits on the left are filled with copies of the higher bit of X. I don't think that's important. We'll just do band. Okay, now we want to do, okay, that's and. It's bands. Let's do but not. Um, see. So that's, wait, but if I do this one, it still gives me -1. How do I like make it display? Okay, how do I make it display unsigned? JavaScript display unsigned number. 0 fill right shift operator. JavaScript bitwise operators except this one. Treat numbers as 32-bit, signed 32-bit integers. Unsigned number. Oh my gosh, yes. Okay, so what I'll do is, as long as this, okay, we'll see. Okay, so would this compile though? Would it compile to the box type? Shift and bit shift R shift. Yeah, okay, so that should be good. What is triple R shift JavaScript? Oh, because it's unsigned. Oh, because the arithmetic shift. So that's okay. Is Lua bit32.rshift equivalent to JavaScript uh left shift? Oh no. Oh. No. AR shift. No, it is AR shift. Okay. So JavaScript. Just or with 0. Okay. Okay, this seems be not. Okay. Now we do okay, what do we do? Be and, be or, okay. Be not, and then be or. Okay, we'll do this. And then we'll do, be test. Returns a boolean signaling whether the bitwise end of its operands is different from 0. Okay. I don't think we need that. Be XOR, yes. Sure, we'll do that. Extract. I don't think it returns unsigned number formed by the bits field to field plus the width minus 1 from n. Bits are numbered from 0, least significance. Okay. What is width? Oh. Okay, let's just do R shift or something. Let's do L shift. Okay, that's not a thing. Do R shift. I feel like extract might be useful. So A, I guess, I guess we do and we bit shift to the right by B, I guess. Wait, no. We want to get the power of B. Wait, what? No. We want to AND 2 if we bit shift it to the left. No, 1. Bit shift to the left by B. And then we bit shift this to the right by B, I think. Is that it? Wait, let me check. So let's say we have 1, 2, 3, 4. So console.log lua bit 32. Sorry, b extract. Yeah, sure. Wow. Okay. A, and then b1 is gonna be what? 0, 1, 2, 3. Let's do 3. Place number 3. Right, and we do 4. Let's say 0, 2, 3. Okay, good. So now I want to replace. Okay. Replace C1 number, B1 number, B1. Okay, and then now we just do you do XOR. How do you replace a bit? How do you like set it to how to replace a bit using bitwise operator? Universal formula to modify a bit of position P starting from 0 for the least significant bit with a number n with a new bit value. Okay. So let's just steal this from, it says it's universal anyway, so whatever. Result is equal to, so the n is a. Okay, so this is going to be a. So a and, wait, let me just like, nope, what the heck. There you go, we're just gonna steal this formula right here. Oh wait, never mind, because like, wait, I'll do this. Whoa. Okay, how convenient. So a1, no, not a1, we just want a and not 1 to the left, what's p? Position p, so that's b1, I'll just b, and then do that, or that with b to the left, right, left, wait, what? No, b is the new value, so, wait, yeah, the v well, in this case it's B, and then B, there you go. So, replace, if you want to replace this with, position 2 with, 2, with 1, 12, okay. A dot to string. Okay, so I think that works. Um, hmm. Let's see now. Um, okay. There you go. Okay, so I think that works. See here. So, yeah, so all of these are little library functions, but I think A, B, yeah, so I can just return those values. Nope, wrong one. Here. So this should be, it should return a number. Okay, good. So this should just be return A and B. That's going to be commented, and this is not, so not A. Right, it should be A1 and B1. A1. return A1 and B1, or B1, return A1 XOR B1, return A1. Wait, no, I think it's just bit 32. No, I should directly call the function. Okay, let me take all of this and put it into, not all of this, but just these binary functions. There you go. And then I'll just directly do bit shift dot band A1 and B1. Return bit 32 dot band of B not A1. Okay. Yeah, so this seems to be it seems to be great. Okay, nice. So these are gonna be my functions, I guess. I'll just replace these, but I'll just, okay. Um, I'll just copy and paste this, I guess, to here. Um, yeah. Yeah, so this is gonna be my, I guess, library sort of thing. Or if I say it right, it's not important. There you go. So I'll just save this as, what do I save this? What do I call this? Okay, custom architecture, I guess. Computer virtual machine architecture. Nope. There you go. I saved it. Okay, good. I'll like fork this so that alright. Alright, so I'll fork this once I end the stream so that it doesn't what's it called? So that you guys can't access and like edit a whole bunch of stuff here. I don't want y'all to do that. Although I don't know if JS Fiddle would account for like our different IP address, because your IP address is gonna be different from mine. But whatever. But yeah. So now all I have to do, well, all as if I can finish it on time or finish it like really quickly. The answer is no. But what I have to do now is just decide on the computer architecture. So what is going to be the instruction set? How it instructions. I think it should be like this. Yeah, I feel like this would make more sense, you know? Computer architecture. What does it have? CPU? Yeah, I think that would make more sense. CPU, what? 54-bit instruction set, I guess. So what is it gonna have? Instructions. It's gonna be in hex. So first of all, structure. Opcodes, I guess. It will do RAM. Each segment is 32 bits. Yeah. It's supposed to be, well, each segment is 64-bit double. Yeah, the 64-bit double. Okay. Um, let's do like, so like, okay, 1, 2, 3, 4, 5, 6, 7, 8. I guess that's, yeah, that is isn't it 16? Okay, no. How many hex digits in 64-bit number? 16? 16. Oh, wow, that's a lot. So I guess you could do like, maybe what I could do is, the first 5 could be, I don't know, cause okay, I guess the first 4 could be like A. So like A means what? Is the opcode. Um, it's a 64-bit byte, except each instruction set. I think it's only usable if it's like 32 bits or something. Um, so I think it should just be like this. So I think that's way too many outputs. That's way too much space. I think A would be good enough. Yeah, I guess we could make space for up to 256 instructions. Here's the thing, right? Let's say we want to like initialize a register. Like, how is that gonna work, right? Because then we need like 64 bits of like data. I don't know. 64-bit registers, 32-bit instruction set. I don't know if that makes sense. It's like I think it's only usable. Um, Okay, here's the thing, right? Because, yeah, this is a 64-bit double, but when we do like the integer operation, bitwise operations, it's just like the least significant 32 bits that's usable. So that's like what I'm thinking. So, um, unusable for instructions. We're also gonna need the registers, so. So instruction pointer and stack pointer. I think that should be good. Um, I should probably say like what code is it? Hmm. I guess for the move instruction, I'm thinking it's like setting um a register to the value of another register. Um, I'll just do 1 byte. Hmm. No, not 1 byte. 6 bits. No, 8 bits. No, 4 bits. Let me make this argument readable. Okay. So the first argument, um, data, uh, arguments, uh, I don't know. The argument should like, what's it called? what's it called? Argument should. Okay, my brain is not working anymore. Should it be like little endian or like big endian? If four arguments, if two arguments, one argument. I think like this would work. I think that would make sense. Okay, it's 4 bits. So, I mean, do we have enough space? Let's do not 2 bits. They literally have like, this is a byte, literally. Hmm. Okay. Okay, I guess I'll just end the stream here because like my brain is not working anymore. I guess I can work on this tomorrow. Alright, bye.